Welcome to our podcast on solution development. This will involve a discussion about the different packages that we use in the computer application technology subject, like word processors, spreadsheets, databases, and web design. These topics are from question 7 of the 2024 Computer Applications Technology November Theory exam. And this is for IEB students. There are 3 ways that you can engage with the content of this podcast. If you want to test your knowledge, then download the questions covered in the video by getting a PDF with the questions from the link in the video description. Then you can attempt these questions and then come back and listen to the podcast and compare your answers. Or if you want to use the podcast to learn new information, then first listen to the discussion, then download those questions that we mentioned earlier from the PDF in the video description, and then test yourself to see how much you remember from this discussion. Or you can simply enjoy the discussion and learn more about solution development. So now let's hear what our podcaster has to say about all these different packages.
Okay, let's get into it. We have all had this moment. You are right up against a deadline, you spend hours on a project, and you go to open that one crucial document. The instructions, maybe?
The rubric.
Exactly. And you click, and you just get nothing. Or even worse, that file not supported error. It's just this instant panic.
And that feeling, that panic, is the perfect entry point for what we're talking about today. It shows why solution development is really the core of computer studies. It's not just about theory. It's about having a practical plan for when things, go wrong.
So today we're doing a deep dive into those fundamentals. We're looking at the everyday stuff, Word and Excel, and turning those common frustrations into real, actual problem-solving skills.
Yeah.
Moving you past just hitting the panic button.
Right. Our mission here is to pull out specific, actionable answers. We're covering file handling, document formatting, getting calculations right, and something that is so critical, data integrity. These are real problems that students and teachers deal with all the time.
So let's start right there with that crisis scenario.
Yeah.
The file you can't open, you get an important email attachment, and it just won't open. What are the practical steps you can take beyond just, freaking out?
The great thing is there's a clear logic to troubleshooting this, and the most common reason is compatibility. It's almost always tied to software versioning.
Meaning someone has the shiny new version and I don't.
Precisely. So the first solution is really about prevention. The person sending the file should try to save it in an earlier or a lower version. That gives it the best chance of being opened by anyone.
Okay, that's great advice for the sender, but I'm the one staring at a file I need to open right now. I can't wait for them to resend it.
And then you have to look at your own environment. Step 1 is to just double check that you're on a machine that actually has the correct software installed. It sounds so basic, I know.
But it happens.
It happens all the time. But okay, let's say the software is definitely there, it's the right program, but it still won't open the file.
What's next?
The next step is to check for updates. You might need to download and install a patch. Developers release these small updates all the time, specifically to fix little compatibility bugs like this one.
Okay, so versioning, environment, patching. What if all 3 of those fail? Am I just out of luck?
No, there's one more big step. You need an alternative way in. You should try opening it in a totally different program. The source material brings up a great example, like trying an open source tool like OpenOffice.
Because it might be able to read the basic file structure even if the main program can't.
Exactly. So the takeaway is a file that won't open isn't a dead end. There's a strategy. Version, environment, patch, alternative. You work through the list.
I like that. A systematic approach. Okay, so now the file is open. We've solved that crisis. Let's talk about building the document itself and doing it efficiently, specifically in word processing.
Oh, this is a big one.
Right. Everyone knows how to put a picture in a report, but then they just, type figure 1 manually underneath it.
And that one small act is probably the single biggest mistake people make when they're creating long professional documents. It feels faster in the moment, but it guarantees errors later on.
So what's so catastrophic about it? Tell me why using that built-in automatic caption feature is so much better.
It's not just one thing, it's a whole system of failures you're creating. But using the feature gives you, let's say, 5 huge benefits. First up is just visual consistency.
Okay.
Your captions are always positioned in the exact same way. And the format, the font, the size, it's always consistent. No manual tweaking.
That makes it look more polished, I get that. But where does the real power come in?
It's the dynamic part. Those automatic captions will update whenever you make a change.
What kind of change?
Any change. Let's say you realize that figure 5 really needs to be at the beginning of the document. You just cut and paste it.
And then I have to go and renumber everything by hand. Figure 1 becomes 2, 2 becomes 3.
No, that's the magic. The software does it all instantly. They are automatically numbered consecutively. You move it, it renumbers itself and everything after it. It removes that human error completely.
Wait a second. If they're automatically numbered like that, does that mean the document sort of sees them as structural elements?
That is the most important part. Yes, absolutely. And that leads to the final critical benefit, indexing. Those captions will automatically show up in a table of figures or a table of graphs.
So if you type them manually, that table will just be empty.
Completely empty. Using that one feature is the difference between just typing and actually designing a robust, navigable document solution.
That makes so much sense. Okay, let's pivot from words to numbers, spreadsheets.
Yeah.
There's a piece of terminology here that I think trips a lot of people up, but it's essential. What is the real difference between a formula and a function?
This is such a crucial distinction, especially when you're trying to figure out why your spreadsheet is giving you the wrong answer.
Okay, let's clear it up.
A function is, it's a pre-built calculation that's already in the application. Think of it as a tool in a toolbox, like SUM or average or count.
So the software already knows how to do the math for those.
Right. You don't write the logic, you just tell it what numbers to use. A formula, on the other hand, is what you build. It's the instruction you write. It's a combination of cell references, operators like plus or minus, and so on. You know, when you type equals A1 plus B2.
So the formula is my custom instruction, and it might use a function as one of its tools.
Perfectly put. And this is why it helps you debug things. Because if your SUM total is wrong, the SUM function itself is almost never broken.
Right, it's been tested a million times.
Exactly. So if the result is wrong, it means your formula is wrong. You've probably told the SUM function to look at the wrong range of cells. You wrote SUM A1.A10, but the data actually stops at A9.
Ah, so knowing the difference tells you where to look for the mistake. It's my instruction, not the tool, that's the problem.
It puts the responsibility for the logic back on you, the developer,
Yeah.
which is exactly where it should be.
Okay, so if functions and formulas are about getting the right calculation, let's talk about protecting that calculation from bad data in the first place.
Data validation, yes.
Let's use a common example. A teacher entering marks as percentages. I've heard horror stories about someone accidentally typing a mark of like 1,000% instead of 100.
And that one tiny error can throw off every single average, every report. It's a disaster. And that's precisely why you have to build in a validation rule. It's about building a robust solution from the start.
So how does a little rule actually stop a person from typing the wrong number?
The rule is attached to that specific field, to that cell, and it acts like a gatekeeper. It literally restricts the values that are allowed. So it can restrict any value that's more than 100 or less than 0.
And what happens if the teacher tries to enter a 105?
The system just rejects it. It will pop up an error message and force them to enter a correct value before they can even move on. It's your first line of defense for data quality.
So what's the actual code? What's the syntax a student needs to know to make this happen?
It's actually very simple, which is the beauty of it. The rule needs to check both the bottom and the top of the range. So the syntax you'd use is greater than or equal to 0 A and D, less than or equal to 100.
Just 0 and 100. That's it. This
Yeah.
seems so simple for such an important job.
It is. Some programs might even let you just phrase it as between 0 and 100. But either way, it forces every single piece of data to follow the rules you set. It's not just about catching mistakes, it's about guaranteeing the quality of your entire solution right from the moment of entry.
We've really covered some serious ground today. We went from solving a file crisis with versioning to making documents more professional with auto captions to clarifying the language of spreadsheets with functions versus formulas
And then protecting all of it with a validation rule.
and protecting it with that powerful little rule, 0 and 100.
And you see the theme, right? All of these seemingly small things, saving a file correctly, using one specific feature, writing one simple rule, they aren't just tricks. They are the building blocks of real professional solution development. They build in accuracy and efficiency.
They protect your work from simple human error.
They do. And that reliability is absolutely everything. And here's a final thought for you to take away. Just think about the sheer amount of data that gets entered every day, all over the world. School marks, sales numbers, inventory, everything.
Yeah, it's staggering.
So if the systems they're using don't have a simple two-part rule like the one we just discussed, how much of that global data is just fundamentally wrong because of a typo? That tiny bit of code is the ultimate gatekeeper of quality. And if you, as a developer, don't build that gate, you're basically just opening the door to chaos.
The content from this video is particularly in our channel for IT and CAT, but you can also follow us on TikTok at Mr. Education. Leave a like, leave a subscribe, leave a comment. We'd love to hear from you. And remember, don't do it the long way, do it the Mr. Long way.